Okay, guys, so I would like for us to look at integration. Now, integration is basically the reverse process of differentiation. Integration is basically the reverse process of what we've been doing all along, which is called differentiation. Now, under differentiation, we said if you're given a function y is equal to, let's say, x cubed, then differentiating it dy dx, you get 3x squared. So basically, integration is the process of coming back to this function. It's the reverse process of differentiation, coming back from this function to this function here. That's what we call integration. Now, here are standard integrals of basic functions. So, for example, if you have an arbitrary algebraic function and then you're being told to integrate, this is how you go about it. So we can take up this example here, 3x squared, we want to get this one. How do we go about it? So we have 3x squared dx. We want to integrate this. What will this give us? Following this procedure here, we have a, our a corresponds to 3. So 3x raised to power 2 plus 1 over 2 plus 1 plus c. So this basically gives us 3x cubed over 3 plus c. This goes, we get x cubed. We get x cubed. Now the plus c basically, we write plus c when the range of integration is not defined. When we've not been told we're integrating from what point to what point. So always we will write the plus c. This type of integrals where we have plus c are called indefinite. Indefinite integrals. So guys, it's very important for you guys to note the standard ways of integrating an algebraic function. We integrate it this way. If we have a cos function, then it will be cos ax. Integral will be sine ax over a. If we have sine ax, the integral will be minus cos ax over a. If we have exponential ax, the integral will be exponential ax over a. And if we have integral of 1 over x, note one thing, 1 over x is basically, if you're told to integrate 1 over x, this is basically the same as x raised to power minus 1. So note, we are not going to use the algebraic method when the power is minus 1. When the power is minus 1, this will obviously just give us an ln. So note, in this algebraic form, we will use all this for integrating. We'll use this method for integrating apart from when n is equal to -1. When n is -1, then we are going to use this method here to integrate. Now, if we generally have a function written on the denominator and on the numerator we have its derivative, then the integral of the whole of that is basically the ln of the denominator. Okay, fine. Let's take up a few examples and see how exactly we integrate them. So integrate the following functions. So our first example is integral of 5x squared dx. How do we go about integrating that? So as we've said, looking at the standard way of integrating an algebraic function, this will be 5x 2 plus 1 over 2 plus 1 plus c. That will be our answer. So that is 5x cubed over 3 plus c. B, let's say we have integral of 4 plus 3 over 7x minus 6x squared dx. How do we go about integrating that function? Now, one thing you need to know is that the integral sign is linear, so we can distribute it over addition and subtraction. So I can write this as integral of 4 dx plus integral of 3 over 7 x dx minus integral of 6x squared dx. Then integrate each one of them. The integral of 4 is the same as 4x raised to power 0. okay, because x raised to power 0 is 1. So integrating it, that will be 4x raised to power 0 plus 1 over 0 plus 1 plus 3 over 7. Integrating x, that will be x 1 plus 1 over 1 plus 1 minus 6. Integrating x squared, that will be x 2 plus 1 over 2 plus 1. And finally, plus c, because the range of integration has not been defined. So this basically simplifies to 4x plus 3 over 7, x squared over 2 minus 6 over 3 x cubed plus c. You can go on and simplify this further. Let's take up another example. Example C. So you're told to integrate 2x cubed minus 3x, all this divided by 4x dx. Now we'll first of all start by simplifying this so that you can be able to see it clearly. So this is the same as 2x cubed over 4x minus 3x over 4x dx. As I said, the integral sign is linear. You can distribute it over addition and subtraction. So this is the same as, let's first of all simplify. So this will be 2, and this will give us integral of 1/2 x squared dx minus integral of 3 over 4 dx. And what does this give? So integrating 1/2 x squared, we will have 1/2 x 2 plus 1 over 2 plus 1 minus integrating 3 over 4. So 3 over 4 is the same as 3 over 4 x raised to power 0, because x raised to power 0 is 1. So x raised to power 0 plus 1, 0 plus 1 plus c. So finally, this gives 2 plus 1 will give 3. So 1 over 6 x cubed minus 3 over 4. 0 plus 1 is 1. 0 plus 1 is 1. 3 over 4x plus c. So basically, that's how we go about just differentiating arbitrary algebraic functions. Let's differentiate this as well. Sorry, integrating. So let's integrate this as well. Integral of 3 over x squared dx. Now, in order for us to integrate this, we'll first of all write it in the standard way. So this is the same as bring x onto the numerator. It will be 3x raised to power minus 2 dx. Okay. So after that, then use the standard way of differentiating an algebraic function. This will be 3x raised to power minus 2 plus 1 over minus 2 plus 1 plus c. So what's going to be the answer for that? So that will be equal to 3 minus 2 plus 1 is x raised to power minus 1. All this divided by minus 1 plus c. This is just the same as minus 3 over x plus c. Okay, fine. Another algebraic function. Let's say you're told to integrate. Find the integral of minus 5 over 9 the fourth root of t cubed dt. So we'll first of all start by writing this in the standard way and just like really bringing t onto the numerator. So this is the same as minus 5 over 9. T is raised to the power 3 over 4 down here dt. This is the same as, I can write minus 5 over 9 outside the integral sign so that I have, bringing this t on top, it will be 3 raised to power minus 3 over 4 dt. Okay, now integrating that, so we'll have minus 5 over 9, t raised to the power minus 3 over 4 plus 1 over minus 3 over 4 plus 1 plus c. So you can go ahead and simplify that. So basically, that's how we go about integrating standard algebraic functions. Okay, let's take up the integral of this. So what is the integral of 5 exponential 3x dx? From the standard form of integrating algebraic functions, you can write 5 outside and then you have integral of dx. Look at the standard way of integrating an exponential function here. So if you have exponential ax, the integral is given by exponential ax over x over a plus c. Okay, let's come back to our question. So this is going to give us 5 into exponential 3x over 3 plus c, which is obviously 5 over 3 exponential 3x plus c. So basically, that's how we go about integrating this standard functions. Now, what if we are told to integrate some definite integrals? We are given some definite integrals to work out. So definite integrals, this is whereby the range is defined. So we will really not have a plus c, but we will have an actual answer in terms of a particular constant. So let's say, for example, you're told to integrate. So integrate from 0 to 1 x raised to power 6 dx. Now let's first of all start by integrating x raised to power 6. It will be x 6 plus 1 over 6 plus 1. And that will give us, so, and the range, you put it on this other side now, the range is from 0 to 1. This is x raised to power 7 over 7, range is from 0 to 1. So how do we replace the range 0 to 1? So we first of all work out with 1. You replace 1 in this equation, your answer here. So I'll have 1 raised to power 7 over 7 minus, you now replace 0, the value down here. So 0 raised to power 7 over 7. That's how you evaluate when you're given a range. So this will basically give us 1 over 7 minus 0, which is 1 over 7. That's how we go about evaluating definite integrals. So as you can see, we no longer have a plus c, but we actually have an actual answer. Okay, let's take up another example. Let's say we are told to integrate from 1 to 2 4 exponential 2x dx. So first of all, let's start by integrating 4 exponential 2x. That will give us 4 exponential 2x over 2, okay? And the integral is from 1 to 2. So this will be equal to, first of all, if we simplify this, we'll have 2 exponential 2x integral from 1 to 2. So this basically implies we replace with 2 where there's x the first time, minus we replace with 1. So we will have 2 exponential 2 into 2 minus 2 exponential 2 into 1. So that is what is going to give us our answer. So we just evaluate this, and this will basically translate to 2 exponential 4 minus 2 exponential 2, and this is equal to 94.42. Another example of a definite integral. So another example of a definite integral, let's say you're told to integrate. So integrate from 1 to 2 4 cos 3t dt. Now, the integral of 4 cos 3t will be 4 sine 3t over 3. And we are integrating from 1 to 2. So we go ahead and replace the ranges. We will have 4 over 3 sine of 3 into 2 minus 4 over 3 sine of 3 into 1. Okay, so that's how we go about this one. So you can go ahead and simplify this. This will be 4 over 3 sine of 6 minus 4 over 3 sine of 3. In order for us to get the answer, you can go on, convert this and this into degrees because they're in radians, obviously. Recall, 1 rad is equal to 57.3 degrees. So you can go on and evaluate that in your calculator. Okay, so if you do it correctly after the conversion, you should be able to get that this is equal to minus 0.5607. Okay, so basically that's how we go about evaluating integrals. One last example Let's say you're being told to evaluate the integral from -1 to 1 of -3/4 t squared dt. Now I can write the -3/4 here, then integrating t squared, that will be t cubed over 3. We are evaluating from -1 to 1. This 3 goes with that 3, so I have -1/4 t cubed. The range is from -1 to 1. Let's now replace the range. Replacing with 1 the first time, so I have -1/4, 1 cubed, then -1/4, replacing with -1, -1 cubed. That should give me the answer. If you evaluate that correctly, you should be able to get your answer as -1/2. So that's it for standard integrals and indefinite and definite integrals.